Welcome to episode 21 of CipherVibe's end-to-end cloud security architecture course. Centralized logging makes cloud changes, access, workload behavior, and network activity available for investigation and assurance. It must be designed before incidents, not assembled from scattered consoles afterward. We will connect its purpose, design boundaries, implementation path, failure modes, and evidence of effectiveness. Every cloud security layer relies on the ones around it. Logging records identity decisions, network flows, workload events, data access, pipeline changes, detections, and response actions. It is the shared evidence layer that lets every other control be tested and explained. Treat the architecture as a chain. A trusted identity requests an action, a policy makes a decision, a workload or data service enforces it, and telemetry records enough context to investigate later. The first building block is collect authoritative cloud evidence. Enable organization-wide cloud audit or activity logs, network flow and DNS logs where appropriate, identity provider records, workload telemetry, and sensitive data service events. Document what each source proves, its latency, retention, regional coverage, and owner. The second building block is protect log integrity. Route logs to protected destinations separated from routine workload administration, restrict deletion and policy changes, use immutability or write-once controls when appropriate, and alert on log disablement, delivery failure. Or retention reduction. Treat logging configuration as a high-value control plane. The third building block is design retention and access. Set retention based on regulation, incident investigation needs, detection windows, and cost. Give investigators appropriately scoped access, protect sensitive log fields, and tier storage without creating hidden gaps. Logs often contain tokens, identifiers, and business information even when teams call them operational data. The fourth building block is monitor the logging pipeline. Monitor source enrollment, last event time, delivery latency, parsing health, access errors, volume anomalies, and schema changes. Build dashboards that reveal where evidence is missing, not only dashboards that visualize the data that successfully arrived. Use this reference pattern. Begin with an explicit policy that describes the permitted outcome. Enforce that policy at the closest reliable control point. Route decision and activity evidence to protected storage. Then give an accountable team a tested path to review exceptions, correct drift, and respond to violations. A defensible logging design centralizes authoritative events in protected storage, grants investigators limited search access, retains evidence for stated needs, and continuously monitors collection health. Implement this layer in a sequence that preserves evidence and limits blast radius. First, inventory required evidence by incident and compliance use case second, enable organization-wide audit and key network sources third, route logs to separated protected destinations fourth, set retention, access, and redaction rules fifth. Monitor delivery health and test log disablement alerts prefer pilots with a named owner and rollback plan over an unmeasured organization-wide switch. The best rollout is one where a normal workflow succeeds, an unsafe path fails closed, and the team can explain the decision from logs rather than intuition. Security architecture fails most often through assumptions, not dramatic movie-style attacks. First, collecting control plane logs but no application or data access evidence second, letting workload administrators delete the logs that record their changes third, keeping logs without knowing who can search sensitive fields fourth, assuming a configured trail is delivering complete events. A configuration screen is not assurance. Collect evidence that the intended control applies to the correct scope and that violations become visible. First, test a representative identity, network, deployment, and data event end-to-end second, measure account, region, source, and retention coverage third, alert on disablement, delivery failure, and retention changes fourth. Verify immutable storage and investigator access boundaries, test both normal activity and a safe negative case in an authorized environment. Record the expected decision, the evidence location, the owner who reviews exceptions, and the rollback method. Repeat after platform changes, new integrations, or major shifts in business use. For a practical exercise, draw a logging architecture for a fictional multi-account cloud organization and list the evidence needed after a public storage incident. Use synthetic information or an environment you own or are explicitly authorized to administer. Deliver a one-page diagram, a concise control statement, a list of expected audit events, and one test for an allowed path plus one test for a denied path. This artifact is more valuable than a screenshot because it explains the reasoning behind the configuration. Before scaling this layer, ask 5 review questions. Which assets, identities, or environments are in scope? Who owns the desired state and exception decisions? Which enforcement point can reliably apply the rule? Which records prove the decision and retain enough context for an investigation? And how can the organization revoke access, contain impact, or roll back safely when a control fails? Good architecture makes these answers explicit and testable. The key lesson is that centralized logging becomes dependable only when design, policy, enforcement, evidence, and ownership move together. Document the decisions you make, remove permissions and exposure that do not support a real requirement, and rehearse the paths that matter before an incident forces the lesson. Continue through the next episode to connect this control layer to the rest of the CipherVibe cloud security architecture.